So we're going to have a look at using Euler's method to estimate a point on a function, and we're going to use a spreadsheet to do it. So using a spreadsheet can save a lot of time, especially if there's a lot of steps. So here's the question at the top, so take a moment to read through that. So starting from the end, we're told our value of y when x equals 1 is equal to 2. We're told our gradient function, told the step length, and this is what we're being asked to find out, the value of y when x is 1.3. So this is really just to show you how to use the spreadsheet to do these calculations if you're not familiar. Now, our r values, this is, we start off with r is 0, and then I'm just typing into the cell what our r values are, and our 3 is as high as we want to go. But there's a way of putting these values in using a formula which I want to show you to start off with. So let's delete those. And what I want is it to go up 1 each time. So what I'm going to put in here is starting off with an equals. If we want to write a formula, you always need an equals sign. And now what I want to do is I want to tell it it's 1 more than the cell above. So the cell above is A4, so I could type in A4, or alternatively I can click on the cell. Then I want to add on 1, so I'm going to type in +1, enter. It's worked out that 1 more than that is 1. I could carry on and do the same in the next cell down. I could type equals, cell above, +1, but now it's easier just to copy and paste. So Control C, and select the cells I want to copy it into. There we go, it's worked out automatically. Maybe a little bit quicker just to type in the numbers on this one, but if you're going much further, then it is useful to use the formula because it's quicker. Okay, what about our x values? So for our x values, our first x value is 1, that's our starting point. So I'm going to type a 1 into that box. And now I'm going to do something similar. Our step length is 0.1, so I want it to go up that much each time. So I'm going to type in equals. Now I'm going to reference the cell above. And then I'm going to reference the step length. So I could just type in 0.1 here. Possibly that might be easier in this example, but I just want to show you what else you can do. The 0.1 is typed into this cell already, so I'm going to click on that one. So I automatically get RF4, the location of the cell. But what I'm going to do now is I'm going to copy and paste this formula into the cells below. Now, if I just carry on as it is, what I'll show you what it does is, oops, let's go back there, that's at F4, I'm going to hit enter. It's worked it out now, that's what we want for this cell. But if I copy and paste down there, what it's doing now, you'll see it's all the same, it's not changed, and we don't want that. What this cell is saying is, instead of cell B4 plus that, it's saying, right, I'm now 1 cell down from there. So I'm going to do B5 plus 1 cell down from there. So what I want to do is I want to lock this cell in to show that that's how much I add on each time. It's always referencing cell F4. So the way to lock it in is to put a $sign in front of the column and row. So when I copy and paste cell B5, then this should now go up, 0.1 each time. There we go. That's what we want. Again, if we've got a lot of rows, then this will make life very easy for us. Let's have a look at the Y column now. This is where it starts to get a little bit more interesting using Euler's method. So we're told our value of Y for our point 0. So I'll type that in. We don't know the second y value or for 0.1 yet. So we need to work out the gradient first. We know the gradient function, that's here. We know our x and y values. So if we're doing it by hand, we just substitute the values in. But what I want the spreadsheet to do is to work this out, and it will do that. So always start a formula with the equal sign, and then I want, first of all, just want a value of x. So our x value here is in that cell, so I'm referencing that cell. Then I want to add on 2 lots of the y value. So we're going to use the add sign on the keyboard, and then instead of 2 times, I'm going to do 2, then it's the star, so shift 8. That is the times sign on the spreadsheet, and I want to do 2 times this cell here, the y value. So far so good. Next we need to take away 3 times x times y. So I'm going to type in minus 3 star, and then the x cell, then star again, and the y cell, the y value. I've finished now, so I'll hit enter, and there it's worked it out for me. Right, so my gradient function is always the same. So I'm going to, or it's the same formula. So I'm going to copy and paste that cell down. We want to go as far as 1.3. That's as far as, beg your pardon, 1.2 is as far as actually as we need to go. So I'm just going to work out 2 more for us. However, because we didn't know the y values yet, we haven't got the complete gradient function. Okay, how about our y value? Well, if you know the Euler method, you'll know that we can work out our next y value by using our previous y value, add on the step length times the function, gradient function. So I'm going to type in equals, and it's the previous y value plus the step length. Again, I can reference this cell, but I want it to always be this cell, so I'm going to put those dollar signs in. And then I'm going to multiply that by our gradient at the previous point. So star for multiply, and then click on the relevant cell. That's all in, so you can press enter, and it's worked out our next y value. Again, because it's the same calculation each time, then I can copy that formula into the cell or the 2 cells below, and it's calculated our y value for x value of 1.3. We've got our point on the line.